sessions. The first this week, next week, the same time on Tuesday, we will have Andrei Inatsenka from Microbiologics explain us about growth promotion testing, about QC strains as well. And then on the 1st of December, again a Tuesday, same time, we have Enrico Tatti from Biolog, who will explain us a bit more about identification procedures for your own environmental isolates. So, but this week we start with Dr. Ulrich Eikmanns, who is Managing Director at Pharmamedia Dr. Müller. So Ulrich has obtained his PhD in microbiology, and over the years he has built an extensive experience in the development and in the production of nutrient media for the pharmaceutical industry. In 2013, Pharmamedia Dr. Müller, or PMM short, was founded, and since their founding, they basically established themselves as one of the leading suppliers in Europe now for nutrient media. The team at PMM provides high quality media and also custom products that are focused on the pharmaceutical industry, and they have very impressive production facilities in pharma-like clean room conditions. Today, Ulrich will talk to us about some of the new developments in environmental monitoring media. I would just like to ask you all to, if you have questions, to please ask them in the chat box below. And after Ulrich's talk, we can go over your questions and discuss them with Ulrich. So Ulrich, please go ahead and tell us a bit more about the new developments in environmental monitoring media.
Yes, Sam, thank you for your kind introduction, and yeah, welcome to everyone. I'm going to talk a little bit about media, and I would like to show you a little bit what media manufacturers do if they are not selling and producing media, so about our developments which we have for future applications. I will guide you through the slides. So we are working with Labconsult for almost 3-4 years now. Labconsult is our distributor in Benelux, and we have chosen them because they have a lot of experience in the pharma and biotech business, offering a wide range of innovative lab equipment and services. As mentioned before, we have started 2013 with doing our business, and we are expanding our distribution network more and more. And since 2018, we are working with Labconsult. Sam has already introduced myself, so I will jump over this slide. I'm now almost 20 years in this business, 20 years looking into the production development of media. In my former life, I was working at a company called Dr. Müller GmbH, which is now Merck, and I was the head of the product management there since 2001 onwards. PMM, or Pharmamedia, is a small company, relatively small. We are growing, focusing on the media development and production, focusing just on media for the pharmaceutical supplies, pharmaceutical applications, trying to be safe, provide safe media and reliable media. We have standard products as well as customized products, and we try to provide a good service. After roughly 7 years of being in the market, we supply roughly 20% of the European environmental monitoring market for the pharmaceutical industry. Media in general are not really hip. So media are considered to be old-fashioned, and media can be bought in. So hardly anyone in pharmaceutical industry is still producing their own media. And what we are facing is that media are not a topic of any conferences. And what does it mean? It means that at the same time, the media know-how is disappearing. Whereas in former times, everybody was preparing its own media during the education as a biologist or as a technician. In nowadays, you buy in the media and you just do the test on media which are bought in. However, in pharmaceutical industry, you make your own experiences with this media, and you know media validation is tedious. Media are causing a lot of problems, but in any case, media are crucial for the quality of your products. And yeah, so if you're talking about bacteria in general, you may know that bacteria may be very disturbing, but on the other hand, they are really fascinating. And for that reason, I've shown just a few different pictures of bacteria, Staphylococci, Serratia, Legionella, Neisseria. And I think it's just sometimes looks like a wonder if you look at all the different shapes and ways from which bacteria can live. And if you are looking on the further slides, you will see that I have dropped in from time to time different pictures of bacteria. What are the requirements for media manufacturing? The requirements are not coming from any legal requirements. Media manufacturers are not bound to any strict regulation. The requirements for a media manufacturer are mainly coming from our customers. And in the pharmaceutical industry, the requirements are crucial for the production and release of your products. The availability must be proven. The cruciality of the product, quality of the products results in the risk of false positive results or the risk of false negative results. And if you look at these two topics, false positive results could easily be caused by the handling of the product or at the same time by the production environment of the media. Risk of false negative results would be typically the risk that you would not find contamination in one of your products. So this would cause a risk for the patients, and at the same time it could cause a risk for your company as a drug manufacturer, because if you fail to find a contamination, this is really critical for your reputation. And of course, media are a cost factor in pharmaceutical production environments. So you have, on the one hand, the purchase of the media. This is relatively easy to calculate, but you have as well media-related expenses. And of course, there's a dilemma. If the more you pay for a medium, the higher typically is the quality. And that means the more you are willing to pay for media, the lower is the risk to have media-related expenses. If you look at the developments which have been happening in the last years, you can see that for media manufacturing, a lot of things happened. Many of these things you have not even recognized. Others are very obvious. And if you look just over the last 20 years, you can see that until about 2000, many of our customers made their own media. And at that time, typically just TSA or SDA was used. Later on, companies started to look more and more into neutralizers in media. So in Europe, it is quite common to use TSA plus LTHT plates meanwhile. In the US, for example, it's more just TSA plus LT plates. During the last years, then more and more customers are buying in the media. So make your own media is disappearing almost. For critical applications, the customers are meanwhile buying triple-bagged and gamma-irradiated media. The suppliers have been audited, and the last trend is more and more, and I think that's a proof of efficacy of the neutralizers, not just to use neutralizers, but to show as well that the neutralizers are active in inactivating the residues of the disinfectants used. This is just a development over the last year, but at the same time, the quality requirement of the media have increased. Parallel to this, the market has changed. If you are comparing the year 2000 and 2020, then you can see more or less that the market size has changed. 2000, many customers will still make their own media. In our days, almost nobody is making their own media. that means that the market in the pharmaceutical industry has significantly grown. The media composition has changed as well. 20 years ago, almost all customers were using TSA and STA for the yeast and molds. And nowadays, customers are using TSA for both applications, for bacteria as well as for yeast and molds. The amount of STA sold to customers is below 5% compared to TSA meanwhile. Neutralizer composition has changed in the last 20 years, coming from mainly TSA to TSA plus lecithin, twine, histidine, and thiosulfate. What else has changed is the media manufacturing, whereas in the past, media were produced mainly in a laminar flow, in a grade C or D environment. Meanwhile, the media are produced in a laminar flow in a grade C or even in a grade B environment. As mentioned before, media supply has changed from make your own to outsource media, and the media know-how, which has been in the pharmaceutical industry 20 years ago pretty high, has been mainly outsourced to all these processes above to the manufacturers. So the market has changed. At the same time, the media manufacturer have changed, going together with these requirements from the market. And if you look at the product development over the last years, this is just the product development of products within the companies I have worked on in. It's around the 20 years ago, TSA triple-backed and irradiated was the first time really used in the market. A few years later, the product changed from the standard TSA as it was used here, which was having a shelf life of only 3 months, 2 months, to going to TSA long shelf life and room temperature storage product. Another, almost 10 years later, a new neutralizer plate was developed. This was coming out of the requirements of French authorities. However, when developing a new product, you have always a problem that the first generation of such products may have some some features which are not that favorable. And that was clearly shown with this generation of plate. It was fulfilling the requirements of the authorities, but it showed precipitates, it had a very short shelf life, so it was not usable for the customer. Around 10 years ago, the first locking lid plates, mainly contact plates, came to the market, and this has changed meanwhile to a situation that the locking lid plate is the state of the art to use such plate. It's the standard meanwhile. So first the locking lid contact plates, then a few years later the locking lid sedimentation plates arrived in the market. About 4 years ago, we were able to provide a new neutralizer plate, which is second generation, not having the disadvantage of the first generation plates. And I'm going to talk today a little bit about this TSAU Plus plate, and I'm talking a little bit about our newest generation of plates. It's still a development, and it's, as I mentioned, the first generation of plates, so we might see further improvements later on this. And what we are talking about here is a TSA, we call it RS U Plus plate, which means that the RS stands for reduced swarming plate. And what it will do, I will show a little bit later. Besides these obvious product changes, media manufacturers have gone through a lot of non-obvious product changes. And these are mainly changes which you might not have observed at the same time. So the raw material quality is continuously getting better. So there are more possibilities to test. There are more sensitive strains on the market, so you can work on better raw material testing. The amount of condensation which is delivered together with a plate has been reduced continuously over the last year. What else? The amount of cracks and the shrinking of the agar has been reduced. The knowledge about neutralization of residues of disinfectants is growing and growing. And this is growing knowledge, you can of course work on better products. The technology to produce Petri discs, plastic Petri dishes, has been increased, and again this can reduce in more stable plastic and reduction in cracks of the dishes. And there have been many small steps, like a larger wrapping area to make the handling of the plates safer. And all this is ongoing without most of the customers really recognizing that products are really improving here. I've talked a little bit about the raw materials and what it means. I will show in this slide. So what is shown here is you have a typical growth curve. So you have the optical density on the x-axis, and you have the time on the y-axis, on the time axis. And what you can see here, if you test these with Staphylococcus aureus, just the yeast extract in a minimum salt agar or medium, you can see that with one lot of one supplier, you can see growth starting already after roughly 10 hours and reaching an optical density of 0.8. Whereas with the quality of yeast extract of an alternative supplier, you can see that it lasts about 10, 12, almost 20 hours to get the growth started. What does it mean? You can see here that even with the alternative supplier, the optical density at the end will reach the same optical density, is the same density. But it means if you stop your test after a period somewhere in between these two starting phases, you might get a positive result with this raw material, but not with this raw material. And therefore, it is important to always improve the quality of your raw materials. And it's obvious that the result of your growth promotion test depends on the quality of the raw materials. It was just a simple example, and I will now talk a few slides about the neutralization of disinfectants, about the history about this, and a little bit what does really make sense and what does not make sense. I mentioned before that media have changed, and the growing media know-how allows for improved products. As mentioned before, the first generation of neutralizer plate was brought to market around 2007 by more or less all media manufacturers. And this will be one of the topics I'm talking about. The second topic is the reduced swarming plus, which is combined with this neutralizing plus plate features of the U plus plate. This has been requested by our customers already since 20 years, so almost from the beginning when I started in this business, and we never had a chance to really develop such product. And obviously, meanwhile, we have the first chance to provide a good plate for this. The urgency to take care or to find a solution for swarming organisms depends on the occurrence of swarming organisms in your facility. Typically, this is not a continuous problem, but it's a problem which may occur and may reoccur a year later or a few months later, or sometimes even 5 years later. So, neutralization of disinfectants. So we all know that alcohol or schnapps can be used for disinfectant. However, alcohol will only act on living microorganisms and will not react on spores. So disinfection with alcohol does not work to 100%. And that means that instead of just using alcohol, you all are using disinfectants containing other active ingredients of disinfectants as well. And if we are looking at the table in the EP, which is listed at the chapter 2.612, table 2, there's a list of interfering substances listed and their potential neutralizing method. So if you look at this table, it's listing all different components which could interfere with the growth of bacteria. Glutaraldehyde, mercurials, phenols, alcohol, aldehydes, sorbate, aldehydes, quaternary ammonium compounds, parabens, bigonides, again, mercurials, halogens, and complexing agents. And on the other side, it's listing the potential neutralizing method. If you look at this list, then you can get an idea why in typical media, neutralizers like lecithin, twine or polysorbate 80, histidine and thiosulfate are used. Because in principle, if you take these neutralizers, then you have for more or less all of the components listed on the left side, a perfect neutralizing mixture. However, what is obvious on this table as well is if you look at this side, you can see here are many components listed which are still not any longer in use. So glutaraldehyde, we have some disinfectants containing aldehydes in our days, but most of them do not contain aldehydes anymore. And it looks like that aldehydes will be completely forbidden in the European community. Phenols in Europe hardly used at all, bigonides not used, and so on and so on. Mercurials not used at all anymore. So what you can see, this list is pretty old, and this list has not changed, at least not as long as I have looked at the European Pharmacopoeia. And I guess it's in there since more than 50 years meanwhile. If you are looking at the components which are really interesting in our days, which are used in disinfectants in Europe, it's typically alcohol, aldehydes, quaternary ammonium compounds, and again, aldehydes. All the other substances are not really used anymore. And if you look at these for alcohol and aldehydes, you need a certain concentration that these components will be active. And that means EP states, oh, you can just dilute it. And just by dilution, you can inactivate it. And the more problematic components listed here are the quaternary ammonium compounds. And again, if you're looking at these more problematic compounds, it looks like that this lecithin and polysorbate, you should be able to neutralize all your disinfectants. However, what is the problem here? These results for the neutralizing method are typically coming from the manufacturers of disinfectants. And they do not perform their neutralizing tests on agar media. They perform their neutralizing tests typically in liquid solutions. And in liquid solutions, you can apply completely different concentrations of neutralizers compared to an agar medium. And so what is the problem with the EP and USP here? It does not give any concentration in the EP USP, which concentration of lecithin polysorbate has to be used in the medium. And the concentrations active in solutions are not applicable for agar media at all. So we are already here in a dilemma. And if you look at the situation in more detail, then we have more or less the situation that we have two kinds of active ingredients in disinfectants. One are the active ingredients which are volatile, like alcohol, formaldehyde. So these will not leave any residues on the surface and will not interfere with the samples of a contact test later on. However, the disinfections which leave residues on surfaces will create the trouble for your environmental monitoring. And if you are now going back to the next slide, which is the same I had before, then you see that of all the components used in disinfectants nowadays, typically only the quaternary ammonium compounds create trouble. And so the development of a special neutralizing plate was more or less especially focusing on the inactivation of these quaternary ammonium compounds. So what we did, we ran some tests with our plate, and we compared the standard TSA LTHT plate to this TSAU plus plate. The test was made with the main disinfectants used, and in this test we applied the disinfectant directly on the plate itself. And of course we applied the amount of disinfectant on the plate itself which are used in a representative usage of the disinfectants. So it was calculated about how much of the disinfectant is used on the surface, and the worst case situation is then of course that all of the disinfectant applied to the surface would be picked up by a plate. And the recovery rate was calculated in comparison to the plate which was not treated with disinfectant. And if you look at the next two slides, you will see the result. And again, this table is pretty big, but I think you do not have to remember all of it. What is shown here is in principle different disinfectants and the amount of quaternary ammonium compound in this disinfectant per 100 milliliter. So the one disinfectants with the highest concentration of quaternary ammonium compound are listed on the top, and the lower you go on this side in this list, the lower is the concentration of quaternary ammonium compound. And these quaternary ammonium compounds are mainly active on gram-positive strains, and therefore we have tested the recovery rate when applying 50 microliters of this disinfectant directly on the plate. And what you can see here is that with Staph aureus, B. subtilis, Staph epidermidis, you will have almost no recovery or not a sufficient recovery if you apply most of these disinfectants directly on the plate. The same is done in principle with this TSAU plus plate. And what you can see here, again, we have Staph aureus, we have Bacillus subtilis, we have epidermidis, but we have all the other EP, USB strains here as well. We are applying again the same amount of disinfectant to the plate, and you can see it doesn't matter which disinfectant is used and applied directly on the plate. You can find a perfect recovery rate with all strains, with all disinfectants used so far. So now, in the next slide, it is shown in principle the same table, just applying instead of 50 microliters, 100 microliters of the disinfectants. And even with this high amount, you can see that most of the plates show perfect recovery rates. Only the two very strong concentrated disinfectants do show some reduction in the recovery rate, but all the others are absolutely perfect. What does it mean? If you're talking about TSAU plus, it is not a totally different plate compared to a standard TSA LTHT plate. The composition of the medium is based on a standard TSA plus LTH plate. So what it means is that thiosulfate is the substance which is not added to the medium, and instead of using thiosulfate, we are using the alternative neutralizer U+. Why did we want to get rid of thiosulfate? Thiosulfate has some negative effect on the growth, especially of Bacillus species, whereas the U+ neutralizer does not have inhibiting features at all. Why can we get rid of the thiosulfate? If you look at the composition of the different media in the market and today, you can see that thiosulfate is used only in very, very, very tiny concentrations. In pharma time, it was used with 0.5 grams per liter. In our days, it's typically used with 0.05 or 0.1 gram per liter. And this low concentration of thiosulfate does not have any effect anymore on the growth of Bacillus, but it does not have any influence at all. So why do we add it? Because it is expected to be in a medium, but it does not have any real reason to add thiosulfate any longer to any medium. What else is the difference? Thiosulfate has some or is supposed to have some very low effect on quaternary ammonium compounds. However, the effectivity of the neutralizer U+ is very, very stronger. So U+ neutralizer is very good and superior compared to thiosulfate in inactivating quaternary ammonium compounds, biguanides, and other components. What does it mean? It means in principle, if you use TSA U+ plate and you are using at the same time a quaternary ammonium compound as disinfectant, then you will reduce the risk of getting false negative results. This is, on the first hand, only an advantage for all the customers or for all the companies using quaternary ammonium compounds. However, it may mean in the future that when using such neutralizing plate, it will increase your freedom to use a quaternary ammonium compound containing disinfectants. In case you will change or you have to change your disinfectant later on. And this is just a short overview of the neutralizer plates. With the next slides, I will just go more to the reduced swarming plate, which is a development which is pretty new and where we are still collecting data on the plates. And I will just show you what it means. If you are going into the media requirements and reduced swarming, we can see that some of the gram-positive, especially the gram-positive isolates, tend to grow and to swarm over the whole plate. And this is shown just here on the introductory slide. This was incubated for 7 days, and it is a gram-positive bacillus species. And what you see typically on the left-handed side is the plate, the standard TSA LTHT plate. On the right-handed side, you can see the TSR RS U+ plate. When does swarming organisms create trouble? The occurrence of swarming organisms can result in out of specification results. Why? Because the plates cannot be read out due to the swarming, so you cannot be sure that below the swarming organisms you will not have other organisms, and so you cannot count the plate. And for this reason, when you are having such organisms, you cannot correctly determine the quality, the status of your clean room. This is much more typically a problem in clean rooms of classes C, D, and not that much of A and B. However, many customers are using their class A, B environmental monitoring media as well for the surrounding areas. So if you want to use one medium for all applications, then you are running with a TSA LTHT plate in problems. And what was very interesting is that the German CPM is the Association of Chemical Pharmaceutical Microbiologists in Germany, started a discussion about this problem, and almost everyone in this group participated in this discussion, and that was indicating that there is really a problem with such kind of organisms. The problem with swarming organism is that you have different bacteria showing different swarming behavior. So first of all, you have gram-negative and gram-positive bacteria, and the swarming of both is completely different. For example, if with a typical medium used in the medical field, a clad agar, you can almost avoid the swarming of gram-negative microorganisms, but the clad agar does not have any effect on gram-positive strains. And so it's a little bit of a problem that not all swarming mechanisms are identical. And that means at the same time, there is not one solution to inhibit the swarming. So we are focusing here on gram-positive strains. Why do we do this? Because typically the isolate from the environment in the pharmaceutical industry are more gram-positive isolates. So these are the troublemakers. And we collected a collection of whatever, 18, 20 strains from several of our customers to see how our plate works. And it's shown on the following slides. As you can see here, for example, a Bacillus subtilis after 6 days on a standard plate, here on the reduced swarming plate, and you can see that the colony size is significantly reduced. It's still big, but it's smaller. And this would allow the readout of this plate to be more accurate, probably. And so we tested the majority of the plates, and you can see just the different strains here. On this side, it's a Leucinobacillus sphaericus. You can see a significant reduction. Bacillus oceani, the colony is still big, but smaller than here. Aerobic spore former, significantly smaller. Bacillus thuringiensis, significantly smaller. And I think, again, you can see how beautiful microbiology can be. Of course, you don't want to have it, but I think just to look at it is just beautiful. And we have some more strains, Bacillus cereus, not identified aerobic spore former, Bacillus halosaccharorans, and Leucinobacillus fusiformis. So when testing 18 of the strains collected from our customers, the result was that 14 out of these 18 showed a strong reduced swarming behavior. However, 4 of the strains were hardly affected in their swarming behavior, and none of the Penibacilli glucanolyticus were inhibited in the swarming. And it's a little bit unfortunate, but this Penibacillus glucanolyticus is most probably the most common swarming organism in pharmaceutical environments if a swarming organism appears. What does it mean to provide a reduced swarming plate? There are, of course, challenges. It's a compromise, like always in life. So you have to have good neutralizing features, you have to have good growth promotion, and you have to show a reduction of the swarming. But at the same time, this means that other features of colonies may differ. And what we were observing was mainly that some colony size or phenotypes of colonies was changing from shiny to more dry, or from flat to high colony forms. But with Aspergillus brasiliensis, it was very, very obvious that the colonies looked completely different. And this is shown here. This is a typical TSA LTHT plate. And here you have the reduced swarming plate. And you can see, instead of all these big colonies with a lot of micelle and with a lot of spores formed, you can see defined colonies on the reduced swarming plate. And this is shown here a little bit more in enlargement. If you were looking at these colonies in more detail, on the first view, it looked like yeast or candida colonies. But if they were growing a little bit longer, they were showing this micelle as here, as shown here, but it was mainly growing to the top and not going to the side. So it was really fascinating again to see this. So this was the most extreme example. However, it has, of course, some advantage, because we think that it's always an advantage if this correlation can be reduced in environmental monitoring plates, because it means that the risk of contaminating your incubation environment is reduced as well. Okay, so we are almost finished. I will summarize again. So the TSA RSU Plus medium is the first medium offering the combination of an extended neutralization of disinfectants and at the same time a significant reduction of swarming. The plate is available, however, the test for growth of isolates is ongoing. So from the swarming organisms, we could get all the tested organisms to grow. However, we are right now in a test phase where we test with our customers their house isolates, and it looks like that most of the house isolates are growing as well, but some needs to be speeded up a little bit. So it's an ongoing process. and we are very confident that we will be able to provide a really good plate in the near future. And at the same time, we have found some possibility to probably interfere with the growth of Penibacillus, but this is at a very early stage of the development right now. So we are very confident here as well to be able to provide something, maybe not next month, but definitely within the next 1 or 2 years. And this is a slide I would like to finish my presentation. If you have more questions, you're of course more than welcome to contact my colleagues at Labconsult. They will forward all your questions directly to me, and we can try to find an answer. And yeah, please feel free to ask now. Please feel free to ask in the future whenever a question comes across to you. And yeah, time for questions. Thank you very much for your attention.
Thank you, Ulrich, for this nice presentation. Thanks a lot. We have actually two questions from an attendee. She says she's doing research on environmental monitoring in hospitals in low resource settings. And so the first question she asks is that apparently chlorine is still used a lot for disinfection. And for this, you would still need thiosulfates in your media, correct?
No, not really correct.
Okay.
Chlorine is an active, it is chlorine containing disinfectants. You have more a problem, which is a cosmetic problem, than a problem with the media. So chlorine is active as typical as gas. It's chlorine dioxide, which is typically the active substance. And when using chlorine, the active substance will disappear in the gas phase. The problem with chlorine containing disinfectants is that they leave residues on the surface. So it's really ugly to see that, but these residues on the surface of chlorine containing disinfectants are not active anymore. So they do not interfere with the growth promotion of the media. Okay,
great. And then a second question from the same attendee, so also for environmental monitoring in hospitals. They also culture their disinfectants and antiseptics and soaps and so on, because they're described as being a source of hospital outbreaks. And she wonders if you have any experience in culturing these products with U+ plates, or with other media you might have at PMM, if you have recommendations.
We do not have done any tests with soaps or antiseptic soaps or liquids at all. So sorry, would be to be tested and to be compared. I think typically, if you know the ingredients of your disinfectant or whatever, if it's an antiseptic or soap or liquid, you can pretty easily determine if there will be an inhibiting effect or not. Of course, the ingredients of a soap may have an additional effect, but that's independent from the neutralizer used in the medium typically.
Okay, thank you. We have another question coming in. The incubation of our plates is performed at an external lab, one of the attendees says. After sampling, the plates are stored in the fridge until transport to the external lab, so in the fridge at 2 to 8 degrees. Lately, they see a lot of condensation in the CP after sampling and storage in the fridge. So just condense forming after the plates are stored in the fridge. Any recommendations to avoid condensation?
Possibilities to avoid condensation is always to keep the temperatures as stable as possible. So if you're talking about media, other media, you have a combination of a few ingredients and 95% of water. And every time you heat the temperature up, you bring more water in the gas phase. And every time you cool it down, you will reduce the amount of water which can be solved in the gas phase, and that means you will create condensation. So keeping the temperature as stable as possible will reduce the condensation, and if possible, it would be better to store media at room temperature and to keep it stable at room temperature.
Yeah, also after sampling, you mean to store?
To leave them at room temperature and to transport them at room temperature to the sampling lab.
Yeah, and if I'm not mistaken, it's probably also a good way of working, if it's possible, is to store the plates upright, correct? To not tilt them too much, especially if condensation occurs.
It should be always upright, if not used, or if used, always in the same position, because as soon as you turn it to the side, you will see the condensation running out of the plate, and it will be a mess. Yes.
Yeah. Okay. Do we have any more questions? And I don't see anything appearing in the chat yet. I would say to the attendees, if you would have any other questions about this topic for us or for Ulrich, feel free to send us an email or contact us via LinkedIn or via our website. And if that's all, I think we should again thank Ulrich for the nice presentation, and thank you all for attending. This webinar has been recorded, so we will send you another email where with some information of where you can find the recording to share with colleagues that might not have attended, or with any other people that might be interested in this. And then I hope to see you all next week for the next session, in which we will have Andre of Microbiologics explain us a bit more about QC microorganisms and growth promotion testing. So thanks again all for attending. Thanks Ulrich, and see you next week.
Bye.
Bye everyone. Bye.